Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, we'll go through this 5129 Combined Science curriculum. This is for the Cambridge International Combined Science, but it's equally similar to any 14 to 16 years old GCSE or IGCSE Combined Science curriculum. So we'll be talking specifically on this big branch of organic chemistry. In this first question, we have P, Q, R, and S. There are 4 different organic compounds. So P burns completely in air. So this is basically complete combustion. And when they say air, air is a mixture. So this is complete combustion in oxygen, which is around 21% of dry air. This is from the environmental chemistry topic. To give you carbon dioxide, the formula is CO2. Water, the formula is H2O. These are from year 9 chemical formula topic. Now Q is a saturated hydrocarbon. Hydrocarbon means only containing hydrogen and carbon atoms only. Saturated means carbon-carbon single bond only. So this must be the alkane series. Now R has a molecular formula. Molecular formula, this is how many atoms you have in one single molecule. We could see that this is C3H8. So this is actually CN, H2N plus 2, because 2 times 3 is 6 plus 2 is 8. So that is again alkane's general formula. Last but not least, decolorizes bromine water. This is test for unsaturation. So when you have unsaturation, you have carbon-carbon multiple bond. So S is actually alkene. So you're looking for alkanes, which means S cannot be the answer because S is alkene. And then could be alkanes. Alkane can burn completely in air, giving you carbon dioxide and water, yes. Alkane is saturated hydrocarbon, yes. Alkane has CnH2n plus 2 chemical formula, yes. So P, Q, and R are possible. Therefore, that means that A must be the answer you're looking for. Question 2, petroleum is a mixture. So we know it's a mixture of substances, and we could separate into useful fractions by fractional distillation. This works because these different fractions have different boiling points, and they are all simple covalent structure from year 9. These are the covalent bonding. You know that they have weak intermolecular force of attraction between the molecules. Low boiling point, you could boil them, and you can condense them to give you the different fractions in the fractionating column. So bitumen is not used to make waxes, it's used to make road surface. So our road surface are paved with bitumen, so A is definitely wrong. You're looking for correct statement. Gasoline are not used for oil stove. It's not used for cooking. This is actually used in cars as your petrol. Kerosene are not used for buses and lorries, but then we are really using kerosene for aircraft fuel, for aeroplanes, that kind of stuff. And last but not least, these are lubricating oils and stuff, so you can use it to make polishes or stuff. So that one is definitely okay there. Question 3, we have the structure of hydrocarbons. We have carbon-carbon double bond. This represents alkene functional group. You could also work out the total number of carbon, which is 1, 2, 3, 4, 5 actually, not 4. And you can work out the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each hydrogen can only form single covalent bond because hydrogen with 1 electron in the outer shell differs, and the outer shell can only maximize with 2 electrons. Hydrogen always forms single covalent bond. You use it to test with bromine water. So of course, alkene with bromine water, it will get decolorizes. So bromine water becomes colorless. Bromine water becomes colorless. So that is what we're looking for. So B and D are for alkanes. And then the carbon-carbon double bond there is not saturated. It's actually unsaturated, because saturated means carbon-carbon single bond, where all the carbons are completely bonded already with single bonds. Therefore, they cannot do addition reaction. But here, you can add Br across double bond of alkenes, and you can get colorless. Question number 4, we have alkenes. Alkenes have CnH2n general formula, where n is the number of carbon. So which formula does not, this is a negative question, does not represent alkene? So when n equal to 2, 2 times 2 is 4, so this is an alkene. So they are looking for something which is not an alkene. 3 times 2 is 6, so you get 6 there. 4 times 2 is 8, this is 10, so C must not be an alkene. So C is actually CnH2n plus 2, which is alkane. If you look at that, 4 times 2 is 8, plus another 2 is 10. So you know that C is not an alkene, but an alkane there. 6 times 2 is 12, so D is also an alkene there. Question number 5, we have ethene. Ethene is your common case study, C2H form from structure and bonding in year 9 under dot and cross diagram. We know that we can draw these, which is not dot and cross, and a carbon form double covalent bond and a single covalent bond to the hydrogen there. So if I convert this to dot cross, there is dot cross hydrogen, dot cross hydrogen. The other one, dot cross hydrogen, dot cross hydrogen. As for the carbon and carbon, we have that and that because we have 4 electrons being shared all together, 2 from each carbon in order to give us double covalent bond. We're looking at this alkene molecule, which one is actually correct? They can add onto each other to produce polymer. Yes. So polymerization is something that is still quite important in alkene chemistry. Things like plastics, they come from addition reactions of many of these alkene double bonded. They are saturated. That is not true. They are unsaturated because unsaturated means carbon-carbon double bond. They contain carbon, hydrogen, but not oxygen. That's not true. They only have single bonds. That is not true. They still have carbon-carbon double bond in addition to carbon-carbon single bond. Number 6, the names and molecular structures of 2 alkanes. We have methane, we have ethane. If we look at the general formula, CnH2n plus 2 of alkanes. Homologous series, you just add another CH2 in the next member. These are properties of members in the same homologous series of these alkane. So the next one will not be bute. Bute is actually for 4 carbon. Therefore, we're looking for prop. Prop is 3 carbon. So that one is got the prop in the name there. So C3H8 because 3 times 2 plus 2, that is 6 plus 2, that is 8 there. C3H8, the correct formulation. If you draw it out, 3 carbons, and then each carbon forming single covalent bond to the hydrogen. So what I have drawn there, that is what you call propane. You can work out the total number of hydrogen there. 3, 6, 7, and 8 there. Question 7, this is about fractionating column. This is fractional distillation of crude oil there. So boiling temperature of each fraction is different. So you got the top of the column, and that will be the lightest. That will be the lightest, smallest molecule, because that's the one with the weakest intermolecular forces. So weakest intermolecular, inter mean in between the molecule. That is what we are breaking as from year 9's structure and bonding, low boiling point, right? So this one must have the lowest boiling point as you require the least amount of energy to break. And then you go further down, so it will be the opposite further down in the column. So which one is not correct? Or you can say which one of the following is incorrect. Fractions with the larger molecule at the bottom. That is true because the smallest molecule on the top there. So that is true, which means this is not what we want. We want incorrect. Fraction which condense at the top are used as fuels. Well, we got natural gas on top, the biggest constituent of which is we got the natural gas on top actually. What else do we have? Then we have petroleums, which are used as fuels, etc., etc. So I will not discount that yet, but fractions with lower boiling point condense nearer to the top. This one is definitely true. So perhaps this is not true then, because lower boiling point will be higher up at the top. So C cannot be the answer because C is factually correct. Okay, so the column is hotter at the top. Hotter at the top is wrong because you will have higher boiling point further down in the column. And if you have higher boiling point further down in the column, the temperature is higher, which means it must be hotter at the bottom. It must be hotter at the bottom, not at the top. So D is definitely incorrect. So therefore, we got to answer that. Number 8, this is straightforward question. What is the main component of natural gas? This one is definitely methane, CH4. Number 9, you have an alkene. You heat an alkane in the presence of catalyst. So this is long chain alkane. And then you can get shorter chain molecules, shorter chain hydrocarbon. You could get a mixture of them, which could involve alkanes. And the idea is the shorter chain one are more valuable. So these are more valuable because they are more used to it. And therefore, it can bring the oil and gas company further profits in the downstream industry. This is called cracking. You would need high temperature of around 500 degrees Celsius. And as mentioned, you need a catalyst. So catalyst help to speed up the rate of reaction. It makes the reaction faster. Catalysts remain chemically unchanged at the end of reaction. That's from year 10, rate of reaction topic. Question number 10, we have ethene, oxygen, and sulfur dioxide. Only one of the gases is collected. So you can see that this is sodium hydroxide. So sodium hydroxide, the name OH minus there, that is called a hydroxide ion. From the topic in year 10, acid, base, and salt. The pH is greater than 7. This is what you call a base or an alkali. The pH is greater than 7. So what it does, it will neutralize. It will neutralizes the acidic oxide. We also learned acidic oxide of non-metal such as sulfur. So sulfur dioxide, which contains sulfur and oxygen, that one is acidic oxide. The pH will be lesser than 7 when you dissolve that in water. That is from acid, base, and salt topic. How about this bromine? Bromine will react with, it will decolorize. It will decolorize the carbon-carbon double bond of alkene. It will react with the carbon-carbon double bond, which means oxygen is the only one out of the 3 gas which is not reacted. So unreacted with base, NaOH, sodium hydroxide. Number 1, unreacted with bromine, aqueous because they exist as diatomic molecule, dissolved in water, it's a mixture, it doesn't get decolorized. So really we are looking at oxygen as the only gas which is not reactive with these 2 particular stuff. So what is the property of the gas collected? So how do you describe the property of oxygen? Oxygen, double covalent bond between the oxygen and the oxygen with 2 6 electronic configurations. You want to share 2 electrons to complete your outer shell between the non-metal and the non-metal. Therefore, you're left with 4 more electrons just in the outer shell. We don't care about the inner shell as they are never used for bonding. Now it burns with a yellow flame. Not really. It burns with a blue flame. It relights a glowing splint. That is correct. That is the test for oxygen from year 10. Test for gas under experimental techniques and observation, that kind of stuff. Turning lime water cloudy, that is the test for carbon dioxide gas, which is not given in this question. Turning universal indicator red, that one is under acid, base, and salt. So universal indicator turns red in the presence of acid. But then sulfur dioxide already gotten neutralized by sodium hydroxide. So sulfur dioxide doesn't get there at all. Speaking of this yellow flame, oxygen doesn't burn with a yellow flame, oxygen burns with a blue flame. Question 11, ethane gas is heated. Ethane gas, so this is CnH2n plus 2, n equal to 2, so you could very clearly know that ethane from your case study, C2H6. So C2H6 is burned, it gives you hydrogen gas, which exists as these diatomic molecules, which, they form a single covalent bond, H2 diatomic molecule. So what is left behind there? Well, we got to work out the number of carbon and the hydrogen remaining. So that thing there is equal to 2 carbon because there is no carbon there. 6 minus 2, which is 4. So that remaining start with C2H form. This is an alkene. This is an alkene. Carbon-carbon double bond because carbon form 1, 2, 3, and 4 covalent bond. This carbon 1, 2, 3, and 4 covalent bond. This is a 2-carbon alkene, C2H4. To balance the equation, as stated in the question there, it also decolorized bromine. That is the test for carbon-carbon double bond alkene there. Question 12, which statement about hydrogen is not correct? Be careful, this is a negative statement. Hydrogen is used as a rocket fuel. Maybe, maybe not. Well, let's go through the rest first. Hydrogen reacts with ethane. That is not true. Hydrogen reacts with ethene. Ethene, carbon-carbon double bond. When you add it with hydrogen, then you can get CH3, which is C2H6, which is ethane. So it's the other way around. Ethene reacts with hydrogen to give you ethane. Okay, so B is definitely wrong. Which means B must be the answer then, because B is definitely wrong. It's just playing around with words and just being careful with the technical terms. Okay. Number 13. So the diagram shows the structures of 4 organic molecules. Which one are members of the same homologous series? We could see that this one is C2H6. This one is ethane. That's the name, case study. So alkane is the homologous series there. We have alkene, which is the carbon-carbon double bond there. And this CnH2n, general formula, C2H4. We have this thing called OH there and OH there. So P and R are definitely the same homologous series because both have OH, whereas Q is alkane. Q is alkane with the A and E, and then S is alkene. So if you get Q and S together, they are definitely different things, and then none of them have carbon-carbon double bonds, so S with any of them would be wrong there. Number 14, we have fractional distillations to separate out the crude oil, petroleum, into different fractions. What are the uses of the 4 fractions? So bitumen is used to make road. That one is very, very clear. So A and B are out. So oils are used. So these are lubricating oils, by the way. So one of the fraction is called lubricating oils. So that one is definitely as lubricant. Paraffin is not used as aircraft fuel. You're looking for kerosene for aircraft fuel. So paraffin is used as lubricant. And diesel are used for heavy machineries, heavier vehicles. Therefore, lorry, trucks, they use mainly diesel there. So D is the obvious answer there. Question number 15. So when you have large hydrocarbon molecules are cracked, so cracking takes place under high temperature. So temperature means heat. So this is 500 degrees Celsius. But you also need a catalyst in order to speed up the rate of reaction there. CATALYST, year 10, rate of reaction, speeding up the rate of reaction. So the structure of 5 organic molecules which are produced when you crack this long chain hydrocarbon, long chain big molecule containing only hydrogen and carbon atoms. State 1 condition used for cracking. They just want 1 condition, singular. I've mentioned 2 conditions. You can just say, heat at high temperature. So that is around 500 degrees Celsius. So you can say that. or you can say catalyst, but then I'm just going to write in and catalyst because they're supposed to go together, but any one of these should get you the 1 mark according to the question there. Now state all the molecules from A to E. Saturated, so this one is only carbon-carbon single bond. This one must be only carbon-carbon single bond. So if we look at it, this one is alkane. This is CH4, CnH2n plus 2 there, with all carbon-carbon single bond. So this next one is also alkane, CnH2n plus 2, but n equal to 2. There are 6 carbon there, 6 hydrogen there. Okay. The next one we can see the carbon-carbon double bond, carbon-carbon double bond. So both of these are alkenes. Then you get C2H4, C3H6 for the bottom one. Okay, and what else? What else do we have for the last ones? We just have alkane again because they are all carbon-carbon single bond. So 1, 2, 3, 4, 5, 6, and that is 14 there. So we're looking at saturated. Saturated must be alkane, carbon-carbon single bond if you look at the structure. Okay, so we're looking at A, B, and E. They are saturated, A, B, and E. So those are your alkanes. Again, what are alkanes? They are saturated hydrocarbons. So they could ask the question, saturated hydrocarbons, alkanes. So it's a repeat of the first question, just try to confuse you there. Now produce carbon dioxide and water. This is complete combustion. When you burn in oxygen, you get CO2 and water. All the hydrocarbons will do that. So alkanes, alkenes, they both will combust completely in oxygen to give you carbon dioxide and water, because there is no other atoms present in hydrocarbon apart from hydrogen and carbon atoms. All of these are hydrocarbons. So A, B, C, D, and E, they all will burn in oxygen in order to give you carbon dioxide and water if you burn completely in oxygen there. The next one, draw a dot and cross diagram to show the bonding in molecule C. So what we have there, C is ethene. So if you see the carbon-carbons double bond there, let's do the carbon-hydrogen single bond. Dot and cross, 2 electrons giving you 1 covalent bond, one from hydrogen, one from carbon. So I'm going to draw that. And then we have the dot cross hydrogen, dot cross hydrogen. We have a double bond, double covalent bond, 2 covalent bond. 1 covalent bond is going to be 1 electron from that carbon and 1 electron from the other carbon. The second covalent bond will be 1 from this carbon on the left and 1 from this carbon on the right. So altogether, 2 covalent bonds mean 4 electrons that are being shared. That is the dot and cross based on the diagram that was given there. Just for that, 2 marks. This is a year 9. This is a year 9 under covalent bonding. Dot and cross part of the syllabus. Every year 9 student will have been expected to cover that. Now the molecules C and D are members of the same homologous series. What is meant by homologous series? So if we look at C and D, they were both alkenes. They both have the same general formula, CnH2n, and they both have carbon-carbon double bond. So what can we say about homologous series? So members of the same homologous series. So we talk about the properties and the characteristic of members of the same homologous series. They have similar chemical properties, chemical reactions due to having the same functional group. So for example, C and D are both alkenes. So C and D are both alkenes with the ENES, having carbon-carbon double bond and the same general formula. We need to give 2 characteristics. So same general formula here, is one characteristic, CnH2n, 2 times the number of hydrogen compared to the number of carbons, having the same functional groups, therefore similar chemical reaction is another properties. So what you can also say is, you can add CH2, therefore the MR increases by 14. For the next member of the homologous series, as you could see from C2H4 to C3H6, C2H4 to C3H6, this is ethene going to propene. You have added 1 carbon, you have added 2 hydrogen. There's a characteristic thing with homologous series. You just add a CH2 for the next member in the series, and your molecular mass will increase by 12 plus 2 times 1 for the CH2. That's why you increase by 14 there. So this is acceptable as well. Part C, we have this ethene, which is C2H4. So how in the world do we manufacture hydrocarbon C from larger? So this is your starting. And you want to end up with this C2H4 shorter chain or smaller molecules of hydrocarbons. So this is called cracking of the long chain hydrocarbons in the presence of high temperature or heat at high temperature. And you also need a catalyst, as that will help you to have a faster rate of reaction. So again, hydrocarbon C, C2H4, I think this is a repeated question like this. Okay, so just be aware that questions do get repeated. I tell you what, let's make it interesting. Let's change this question to D. Okay, so let's say they want us to draw D. Okay, so D there, if I change the questions, let's say they want you to draw D, which is no longer C2H4 but is C3H6. So there will be a slightly different question. So if we look at C3H6 here, we get a carbon, double bond between the carbon and the carbon, single bond between the carbon and hydrogen, single bond between the carbon and hydrogen. This is a single bond between carbon and carbon. So I can do like this, and I have a single bond between carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So let's have a look. Single, 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 single bond, 1 carbon from carbon, 1 electron from carbon, 1 electron from this carbon. So 2 electrons in 1 covalent bond. Single covalent bond, dot cross, double covalent bond, so 4 electrons, 2 electrons there, 1 from this carbon, 1 from that carbon, single bond, and then the other bond, 1 from there, 1 from there, and then single bond there, 1 dot 1 cross. Just like that, I will get my dot and cross for propene, which is molecule D there. So I decided to make it slightly different there so that we could, see exactly what is going on. I tell you what, let's just remove that totally, and then we can just move these, and that is how you draw the dot and cross for C3H6 molecule D there. In these next questions, so a student investigates the combustion of a hydrocarbon. So combustion means burns in excess oxygen. When you burn in excess oxygen, you're going to get carbon dioxide and water. As it is hydrocarbon, only contains hydrogen and carbon atoms. When you burn completely in oxygen, you're going to get CO2 and H2O. This is ice bath. So ice bath can condense. It can condense the H2O gas, which is steam, H2O steam, into H2O liquid. So X there must be liquid water. But carbon dioxide does not get condensed by ice, as carbon dioxide, it doesn't boil at 0 degrees Celsius, but it doesn't boil at, it doesn't melt or freeze at 0 degrees Celsius, unlike ice, okay? So the ice there will definitely cool down the H2O into H2O liquid. So that means the gas that comes in here is just CO2 only. But there is CO2 and H2O. The H2O there come out as steam because combustion is exothermic. Exothermic is from year 10. Year 10 energy changes. Exothermic means it releases heat energy to the surroundings. And what happened to the surrounding? The surrounding temperature would increase. So the temperature of the surrounding increases. These two are features of exothermic reactions. According to the syllabus, the temperature of surrounding would increase there. Okay, so I better just separate them out so that we are not confused between what we want for the definition of exothermic reaction. So the student thinks that carbon dioxide and water are formed when the hydrocarbon burns. Suggest a chemical the student can use at position X to test for the presence of water. State the observation that shows that water is present. I think you can skip this question because this part of the syllabus is already phased out, so no longer in the syllabus, so not in syllabus for the combined science chemistry anymore. Okay, now lime water contains calcium hydroxide. As you know, calcium from group 2, it will lose 2 electrons to complete the outer shell, Ca2+. Hydroxide ion, acid, base, and salt topic. The pH is greater than 7, is alkaline, is basic because it contains hydroxide ion. We look at the charges of the ion. These are what we call valency, which is the combining power based on the charges of the ions. These are from year 9 chemical formula. And then we do cross multiply. We switch the position. One's from the right go to the left, 2 on the left go to the right. This is the simplest whole number ratio. In primary school, they call it lowest common multiple. You have 2 of this OH minus. Therefore, you have 2 oxygen and 2 hydrogen. We use a bracket. Whatever inside the bracket is 1 oxygen and 1 hydrogen. You have 2 lots of it. So you have 2 oxygen and 2 hydrogen. We use a bracket there. So we got to write a symbol equation. Number 1, balanced chemical equation. Number 2, with the stat symbol. Okay, so calcium hydroxide plus CO2 to give you calcium carbonate. Ca2 plus CO3 2 minus. Can do the same LCM, lowest common multiple exercise. But you just need one of it to cancel the other one because they have the same charge. One of these will cancel out the charge from the other anion, calcium carbonate there. The equation is not balanced because this has got hydrogen, this hasn't got hydrogen. This is your base or your alkali. This is your acidic oxide. Oxide of non-metal is acidic. This is your salt. You do need water in order to give you your neutralization reaction. This is from acid, base, and salt topic in year 10. So we're going to put in water and we have to try and balance the equation. 1 calcium, 1 calcium, 1 CO2, 1 CO3. So you have gained 1 extra oxygen from here. From here, you have 2 of that. So you take away 1 oxygen, you're left with H2O. So this equation is balanced. However, that is just number 1 done. Stat symbol. Calcium hydroxide is aqueous because it's lime water. It's a solution. It's a colorless solution. Colorless solution. So it's aqueous. The gas coming in is carbon dioxide. Test for carbon dioxide using lime water. The lime water goes milky, goes cloudy. So this is your cloudy or your milky precipitate. So it's a solid. And you also produce liquid water, which is a colorless solution. And this solid is insoluble in the water. Stat symbol is the second bit required by this question. In the next part of this question, we got to draw this C2H4 again. I tell you what, so that we've done quite a lot of this C2H4. It's getting a bit a bit boring. So let's just change this C2H4 to C2H6. Now we can see this is CnH2n plus 2. Alkane, saturated carbon-carbon single bond. Before you draw dot and cross, it's good if we can draw the display formula. Carbon-carbon single bond only. The rest is hydrogen, and hydrogen form a single covalent bond as hydrogen share 1 electron to complete the outer shell. So you has got 6 hydrogen around this ethane. This is ethane there. with 2 carbon and the A and E in the name. So each of these is a single bond, so it's just 1 dot and 1 cross. So what can I do here? Perhaps I can do, let me see, you can draw in any way you want, but I just want to find the easiest way. Excuse me. So I've got that dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, cross for carbon, dot for hydrogen, based on my diagram there. So this is your single. This is your single bond between carbon and carbon. So 1 electron from carbon, 1 electron from the carbon, single to the hydrogen, 3 of them, C2H6, according to the formula there. Carbon and hydrogen are non-metallic elements, so non-metals and non-metal, basically between carbon and also hydrogen. What do you call that type of bond? That is called a covalent bond. This is from year 9. This is from year 9 under the bonding concept there between non-metal and non-metal. Now you have an atom of carbon. So that means the number of protons equal to the number of electrons, because atoms have no charge. Atoms have overall no charge. From this formula, we can see the number at the bottom is just your protons or your atomic number. This is the international standard. It's not the notation you have seen in your periodic table. The one on top is just mass number or nucleon number. So nucleon refer to the protons and the neutrons. So that is just the number of protons plus the number of neutrons. I know that is not what the question has asked here, but it's important to recap atomic structure from time to time. They just want the electronic structure. So this is the electronic configuration. It's the arrangement of electrons in your shells, E minus, because each electron has a negative charge. So we have got 6 protons. Therefore, we have got 6 electrons straight from year 9. Electrons in shells. 6 electrons, 2 in the first shell. Maximum is 2 in the first shell. And therefore, you're left with 4 more in the second shell. You are a group 4 element because you have 4 electrons in your outer shell. You are a second period element because the first shell and you fill up to the second shell. So it will look like this, as you had done quite a lot of times since year 9 chemistry. So this is 2,4 electronic configuration. For carbon with 4 electrons in the outer shell, therefore they want to share 4 electrons to complete your outer shell. Carbon form 4 covalent bond, as carbon wants to share 4 electrons in order to complete outer shell. That's the purpose, to fully fill your outer shell, and therefore carbon form 4 covalent bonds. And that is what we do in organic chemistry. When we draw our diagram, we count that carbon form 4 covalent bonds there. Group 4, second period element, second row of the periodic table. As you fill the first shell and the second shell, period 1, period 2, second row of periodic table, 4 electrons in the outer shell, group 4 element. That's all really for this topical test. 14 to 16 years old, GCSE, IGCSE, and all-level combined science chemistry on organic chemistry. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, that's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next tutorial video. Thank you for watching again.